Photocells. So I've been bored lately and I've just been having a lot of photocells lying around, so I've been playing around with them. They're actually pretty interesting. You can make little circuits like this, turn it on, and what you have is a voltage divider, and that can control a voltage. So I could press them like that, and the voltage can go up and down. So that's pretty interesting to control light or something, but what if we want to have some more fun with it? Well, if you take a look at your computer screen, really what is it except a bunch of pixels? And what are pixels except little devices which could vary brightness? So essentially, using a bunch of photocells, you could probably lay them out in a grid and create at least a rudimentary sort of camera. And well, that's kind of what I did. So let me introduce you to this thing right here. Yes, so this is a camera that is made out of photocells. As you can see, it is an 8x6 matrix of photocells. I soldered them together in a little arrangement like this, and there's a big large amount of wires. This is probably like $10 worth of wires coming out of here. So what I'm actually doing is I have an Arduino, and the perfect thing about the Arduino is the Arduino can take in analog inputs. 6, 12, 18, 24, yeah, it's 48. So 48 different analog inputs. Well, you're not going to find that on your basic Arduino. The Arduino does not have 48 analog inputs. Neither does pretty much any other microcontroller you get, even the most expensive ones. So I'm going to have to multiplex it, and that is accomplished using these little circuits right here. So this is an analog multiplexer, so it allows me to basically scroll through different addresses that could select a different pin to measure an analog input or output from. I'm using 6 of these, and that only requires 6 analog inputs, which the Arduino does happen to have. And I'm using 3 of these digital pins to actually address each row. So basically what happens is at any one point in time you're measuring 6 of these. So you're measuring 1, 2, 3, 4, 5, 6, 7, 8. And you're just scrolling through that really fast like a TV basically. And that's how it works. So yeah, that's what it's doing. And if you wonder how, okay, now I'm measuring the values with the Arduino, how to actually make a picture with that. And what it's doing is it's sending it out via serial. There are probably better ways you could do that, but how I have it here is it just sending out all the values as a single string. So basically it's just 48 numbers from 0 to 255 that represent the pixel value. Alright, so that's going out through the serial cable, and I don't want to do a screen recording because, well, I don't want to. And that's going to this Python code. Yay, so we have some Python code. And this is probably pretty sloppy. You could probably replace a lot of this with a loop. But what it's doing is it's having a PIL, which is Python Image Library. And what it does is it lets you create images and edit their pixel contents. All right. And then we have also serial, which let's use serial. So I'm not going to go through everything it's doing here, but it's basically just taking in a string via serial, and then it's basically just parsing out integers. Remember, they are numbers separated by spaces, and it's actually doing some printing here. This is just for diagnostic purposes, but it's going through each of all the lines. And it creates a 640 by 480 picture, and it's basically just a white picture. And now we're filling out each square, so we could actually have a pixel measured with the camera is going to be very small, so we want it to be scaled up. That's what it's doing. It's upscaling it and assigning the values accordingly. And notice how all these are the same. This is because it's a black and white image. So if you wanted a color, you would have it be different, but it's just doing grayscale because you can't measure colors with photocells, as it turns out. So let me just show you what the Arduino code is. I might post this if anyone's interested. So this is actually really simple, just basically scrolling through from 0 to 8 on these 3 pins, and we're measuring the analog values and printing them out via serial. And to actually show what it's doing is, so just a big string. And each one of these lines is a picture that it's taking, and it's always taking pictures. All right, so let's run it. And it's gonna produce an image called PIL color. And it doesn't look like anything at all. Well, that's because it's just kind of looking at nothing right here. Just nothing. So if we want to actually get something recognizable, we need like a clear image. So just to prove you that it's actually working, I'm gonna put a light source here, and we're gonna take another picture, and you're gonna see how it has light now. The pixels will be lighter. Now we're taking a picture. Oh wow, look, now it's lighter. And we can compare this to the previous picture. So this is with the light off, and this is with the light on. Okay, well, now you may be saying to yourself, well, what does this accomplish? A simple photocell could just do this just as well. It has a light in front of it. It could detect whether there's light or not. What we wanted to do is actually resolve some sort of features, or like here. So the pin is diagonal. So we should get at least a diagonal line that's going across the photocells, and that's going for the picture. No line. And look, you could kind of see it right here. It's a diagonal line. Still, that's not really very good at all. So let's try to measure some sort of a shape. And then we could just fold it. This is a very triangular triangle. The triangle and the ability to get this image is basically based off of how good this shadow is. And triangle, triangle, triangle. Not very good. So let's try to and hope we can get a good triangle shape this time. You can see that there's a triangle here. So this proves to me that at least what we have right now works, though it doesn't have a lens or anything which might make it be able to take better pictures. Also, we could adjust the resistor values to make it more or less sensitive. That could be helpful as well. But really what we need to do is just add more pixels. So that's going to entail getting a bunch more of these photocells and making a bigger grid and buying a bunch of more multiplexers. Additionally, what we could do is we could suspend this on a motor mount and have it going up like this and just fill out a square like that across time without having to actually have a bigger array, but then your object that you're taking a picture of will have to be very still. But for right now, I believe we have created the very worst camera that has ever been made ever in human history of all time. But it's a digital camera, so there you go. Have a nice day.